All right, section 5 is about proving parallelograms. And what we mean by that is we're going to be able to look at a figure and say whether or not that figure is a parallelogram, or look at a figure and say, is that parallelogram something else? Can we figure things out about a diagram given some information? So first thing we need to be able to prove is if it is a parallelogram. So if you know you have a quadrilateral and you want to be able to prove that it is a parallelogram, okay, there are a couple things that you need to look for then. If you can show, if by some way you're able to show that both pairs of opposite sides are parallel, then it's for sure a parallelogram. So if you can use your other properties, other facts and figures that we've learned about from before, like alternate interior angles, same side interior angles, if you can use things like that to show that this one is parallel to this one, and this one is parallel to this one. So if you can show that both pairs of opposite sides are parallel, then this figure has to be a parallelogram. That's one way to do it. Okay, another way is to find out that both pairs of opposite sides are congruent. So again, maybe you're using triangles. Okay, you're looking at these triangles and you're able to prove that this and this are the same, because we can see these triangles in here kind of given these diagonals, so we know this side and this side are the exact same, and we know that this side and this side are the exact same. However you can prove that these two sides are congruent and these two sides are congruent, that would mean for sure that this figure is a parallelogram. Even if they didn't say for sure this quadrilateral is a parallelogram, you can say it is once you know that these two sides are congruent and these two sides are congruent. Okay. Another one is by looking at the angles. Both pairs of opposite angles are congruent. I'm going to draw these through the diagonal. So this angle and this angle, if those are congruent, and this angle and this angle. You can't just have like one set. Can't just have these two. Can't just have these two. You have to be able to show that all of these fit like this. These two opposite ones are the same as these two opposite ones. Then for sure, this figure would be a parallelogram. If you can prove this, then that figure has to be a parallelogram. If you can prove that the diagonals bisect each other. So again, we have our orange diagonals drawn in here. If you can prove that this length is the same as this one, and not just that, this one has to be the same as this one. If you can prove that, then for sure this figure would be a parallelogram. But it's only a parallelogram if both of these are true. Last thing we can prove, if just one pair of opposite sides are congruent and parallel. So we don't have to show everything is parallel. We would just say this one is parallel to this one, and at the same time as it is parallel, it's also congruent. If these are both congruent to each other and parallel to each other, then this figure has to be a parallelogram. There's no other way it can possibly be drawn. So these are the 5 ways to show that quadrilateral that is drawn, or that is a given quadrilateral, with these 5 facts, or these 5 reasons, you can show that it is for sure a parallelogram. Proof of a rectangle. If you know that that figure is a parallelogram, if you've already shown for sure it's a parallelogram, and you want to show for sure or prove that it is a rectangle, well, either you can do the diagonals are congruent, so this orange line is the same as this orange line. Now remember, I'm doing the whole orange line and this whole orange line, not just the half pieces. So it's the whole thing is congruent to this whole thing, then this would in fact for sure be a rectangle, as long as the diagonals are congruent to each other. Also, if you can show that there's one right angle, so if this were a right angle right here, this whole thing has to be a rectangle. Because of our properties of a parallelogram, remember, this one and this one have to be the exact same, so I can kind of draw in hidden right angle. It has to be a right angle if this one is a right angle, because we know it's a parallelogram. If this is a right angle, then this one up here, because these lines are parallel, has to add up to 180. So 90 plus 90 would be 180. So this has to be a right angle, and then this would have to be a right angle. So then we'd have all right angles. So you don't have to show every single one. Once you can just show one of them is a right angle, then all of them have to be a right angle, as long as it was a parallelogram that you started with. Okay, so these are the two ways to show for sure that your figure that was a parallelogram, we can now say, yes, if these things are true, it's also a rectangle. Proof of a rhombus, if you know that it is a parallelogram. So if this figure, it was a quadrilateral, you were able to show for sure, oh, it is a parallelogram. Now you want to take it a step further and say, oh, it's for sure a rhombus. Then you need to show one of these three things. You don't have to show each one, just one of them. Any two consecutive sides, or the sides next to each other, are congruent. So if this side was exactly the same as this side. Okay, again, remember properties of parallelogram. This one is opposite of this one over here, so this would also have to be the same. I'm going to do that one in red. This one is opposite of this one, so that would also have to be the same. So they would all be the same, making it a rhombus. You don't have to show each one. You just have to show that these two right next to each other are congruent. And that would show for sure that this thing is a rhombus. If either diagonal bisects its two angles. So we don't have to show both. If this angle right here, or diagonal, this orange line, cuts the angles that it goes to, so it cuts this big angle in half, so that's the same as that. And that is the same as that. It means it bisected this these two angles. If that happens, then this is for sure a rhombus. Okay, you don't need to know both angles are doing, or both diagonals are doing that. You just need to know that one of these orange lines, one of the diagonals, is bisecting the two angles that it comes from. Then it would for sure be a rhombus. Last way to show that it is a rhombus is if you can show that the diagonals are perpendicular. So if this orange line meets this orange line at a right angle. Now these ones don't look like a right angle in this case, but if we could prove somehow that this was a right angle, so that these two lines are perpendicular to each other, that means that this figure is for sure a rhombus. Okay, so one of these three reasons or proofs, if you can show this, then you can say this figure is for sure a rhombus. So let's go with some examples here. If we are given a parallelogram A, B, C, D with diagonals A to C and B to D, and they intersect at point P right here, determine whether the figure is a rhombus, rectangle, or neither. Okay, given the information, if they were to tell us that A to C is the same as B to D, so from here all the way to here, same as here to here. So we kind of have to think, what information is that telling us? What did they just say? Well, technically, they just said that the diagonals are congruent. A to C is a diagonal, B to D is a diagonal, and if they're equal to each other, if they're the same length, then they are congruent. Well, diagonals being congruent proves what? That proves that it is a rectangle. This parallelogram has to be a rectangle if those two diagonals are exactly the same length as each other. All right, the second one, if A to B equals B to C. So A to B is the same as B to C. And again, I know our figure doesn't necessarily look like it is, but if we are able to prove that this length is exactly the same as this length, okay, what does that tell about everything else here? Well, we've got one side and the side right next to it, or the consecutive sides, being congruent to each other. So if consecutive sides are congruent, what does that tell us? It tells us that figure would be a rhombus. So if this is the same as this, the whole figure, the whole parallelogram is a rhombus. And last example here. If B to P, so just this little half, is the same as D to P, just this little half, what does that tell us? Well, again, we need to think, what information did they just tell us? They told us that B to D was bisected, that P is the midpoint of B to D. So that tells us that the diagonals bisect each other, or at least that AC bisects BD, and that really only tells us that it's a parallelogram, and we already knew it was a parallelogram. It was given that ABCD is a parallelogram. So really, it doesn't tell us about whether it's a rectangle or a rhombus. It only proves, again, that it is a parallelogram. So in this case, it would be neither. That didn't prove anything. Example 2, given parallelogram PRST, determine if the following conditions determine a rectangle, rhombus, or a square. So same thing. We've got to think about what it is they're giving us. If P to S equals R to T, so this diagonal is the same as this diagonal. They're exactly congruent to each other. So they just told us the diagonals are congruent, which means it's a rectangle for sure. If P to S, so this diagonal, is perpendicular to R to T. So if these intersect each other at a right angle. So again, what did they tell us? They told us the diagonals are perpendicular, because PS is a diagonal and RT is a diagonal. If the diagonals are perpendicular, what is that telling us? It's telling us it's a rhombus. So we can say that this figure has to be a rhombus because these ones they told us were perpendicular to each other. And if PS equals RT and PS is perpendicular to RT. So if this is the same length as this one and these intersect at a right angle, well, this being equal to this means the diagonals are congruent. This being perpendicular to each other means the diagonals are perpendicular. One tells us it's a rectangle, one tells us it's a rhombus. If this figure is both a rhombus and a square, or sorry, a rhombus and a rectangle, then it has to be a square. We've proven that this has to be a square because the diagonals are congruent to each other and the diagonals are perpendicular to each other. So it has to be a square. Given parallelogram LMNP, state whether each statement is true or false. If LN, so this diagonal, is perpendicular to PM, this diagonal, so it would look something like this, then LMNP is a rhombus. Well, again, what did they tell us? They told us that the diagonals, LN and P, are perpendicular, which tells us that we have a rhombus, which means, yes, true. And this thing is for sure a rhombus. If LN equals PM, so this diagonal is exactly the same length as this diagonal, then it is a rectangle. Well, what did they tell us? They told us diagonals are congruent to each other, which means they're describing a rectangle. So yes, true. This figure would be a rectangle if that information was true. If LN is perpendicular to PM, which would tell us, oh, the diagonals are perpendicular, so it's a rhombus, and LN equals PM, again, that tells us the diagonals are congruent, which means we have a rectangle. So this showed us rhombus, this showed us rectangle, which means in the end we know for sure it's a square. It says then LMNP is a square. Again, that would also be true. Because of this information, that tells us rhombus, that tells us rectangle. Those two together, rhombus and a rectangle, means it's for sure, it has to be a square. And that'll be the end of our 5th video.